Pero. Oh. Ya.
Assalamualaikum and hi, my name is SHAIDATULFAHSHA binti ARFAN.
Hai, Assalamualaikum. My name is NURAMNA binti RAZAK.
Assalamualaikum and I'm NAJWA binti Muhammad NIZAM.
Assalamualaikum. Nama saya Muhammad NABIL bin IMAM SUHAIRI.
Okay, Assalamualaikum. Today I'm going to explain about chromatography. So I'm going to explain about introduction first. First is chromatography is a technique in which the component of a mixture are separated based on difference in the rate at which they are carried through a fixed or stationary phase by a gaseous or liquid mobile phase. As we know, there has two type of phase, such as stationary phase and mobile phase. So I will explain it later. Before that, we need to know about principle of chromatography. Let me explain to you. The components are colored and the colored solute are soluble in the same solvent. One of the components should be more soluble the solvent for obtaining the separation. The stationary phase is the one that is attached to the column or plate of the chromatography. The most common material used for the same is silica gel, calcium carbonate and activate charcoal. It is primarily porous. Mobile phase are the mixture of the solid dissolved in the solvent, consisting of the solid to be separate. As the mobile phase flow along with the stationary phase, it absorbs on the stationary phase and attains separation, such as when mobile phase pass through the stationary phase, the stationary phase that have inside the mobile phase will be absorbed by the stationary phase that have under the mobile phase that move over the stationary phase. Next is stationary phase. What is stationary phase? Stationary phase is a static part, or we can understand it by part that doesn't move at all. In chromatography, the mixture is passed through a fixed substance known as the stationary phase. It gives compound a surface to interact with, which is essential for the separation process. Different chromatographic techniques employ various stationary phase, or when you apply a different chromatographic technique, the stationary phase also can be different. Next is mobile phase. What is mobile phase? Mobile phase is a moving part such as eluting fluid. In chromatography, the mobile phase is the liquid that transports the mixture through the stationary phase. Depending on the type of chromatography, maybe either a gas or a liquid. Such a experiment that we did last week, we use a liquid type. We do a paper chromatography experiment. Different chromatography employ various mobile phase types. Mobile phase characteristics can influence the separation process. We have two types of chromatography, such as planar chromatography and column chromatography. First, I will explain about planar. Planar chromatography is a liquid chromatography in which the stationary phase is arranged in the form of a planar or flat bed and the mobile phase moved by radiation. Example of planar chromatography is thin layer chromatography or paper chromatography that we did in the latest. The last one is column. What is column chromatography? Column chromatography is a preparative technique used to purify compound depending on their polarity or hydrophobicity. In column chromatography, a mixture of molecules is separated based on their differential partitioning between a mobile phase and stationary phase. The different size column could be used for this technique. Normally in gas chromatography and capillary column are used. There has more example of column chromatography such as gas chromatography, high performance liquid chromatography and liquid chromatography.
This is an example of experiment that we have done according to our topic, paper chromatography. Firstly, we put the 17 ml of developing solvent, which is sodium chloride, in a dry 2000 ml beaker and cover it with plastic wrap. Then we lay the filtered paper on a clean table and use microcapillary to place a tiny spot of each of the food colors on the X mark. We allow the spot to dry by waving the paper in the air. Lastly, we put the paper that we have dried in the beaker that containing developing solvent and make sure the spot of the dye above the surface of the solvent in the beaker. Seal the beaker with plastic wrap and allow the solvent to rise up in the paper.
Moving on to the example of the result, as we provide the video of the experiment, we can see the color of the food dye started to separate and spotted on the chromatography paper. To measure the retention factor RF value, we have stated the formula. The distance travelled by the spot should be divided by the distance travelled by the solvent front. We provide the data of the experiment. By referring the data, non-polar solvent tend to move the dyes further up the paper, while polar solvent may result in less separation between the dyes. The composition and concentration of the solvent can also affect the separation of the dye. The solvent system used should be optimized to achieve the best separation possible for the specific mixture of food dyes being analyzed. Next, chromatography also can relate to the industry such as to detect food additive, pharmaceutical and clinical testing, and lastly, pathology and forensic science.
So the next point is to detect food additive. Organic acids are often added to food products to enhance or modify their flavors, or to make the products more palatable and more acceptable to consumers. One such example is the addition of malic acid and sugar to apple juice that has been diluted with water to extend volume. This restores the sugar and acid content and satisfies customer taste. Malic acid naturally occurs in apple juice and is the predominant acid. Therefore, it is sometimes difficult to detect adulteration because the level of natural malic acid varies greatly.
Second is pharmaceutical and clinical tests. Chromatography is used by pharmaceutical business to measure and examine substance for impurities. For instance, chiral substances have two distinct forms as a result of the tiny spatial variation of their atoms. There is evidence that some chiral chemical can be harmful. The safe version of the chiral chemical may be distinguished from the harmful from using chromatography. Vaccination question is also an application of chromatography, which antibodies are the most effective at resisting and neutralizing specific illness may be determined by using chromatography. Liquid chromatography has revolutionized clinical laboratory testing in conjunction with mass spectrometry. And lastly is pathology and forensic science. For investigation of crimes, paper chromatography is useful in the field of forensic science as this process can be successfully carried out with even very small quantities and material. Using these techniques, samples from the crime scene are collected to be analyzed and identified. It can use in DNA and RNA fingerprinting, moreover, to detect the presence of alcohol or chemical in blood. Pathological laboratories use paper chromatography.
So finally, we have come to our conclusion. The purpose of this project was to discover a method for better separating food dye colors and effectively analyze, identify and purify them. The chromatography technique used was planar chromatography using paper chromatography. All the food dye was successfully separated and the RF values was able to be determined using a formula that has been stated in NIZAM. So that's all from us and thank you, bye!